Analyze the continuity of the function f at x equals the absolute value of x minus 3 over x minus 3 at x equals 3. And we want to graph the function to illustrate the situation. Well, we have an absolute value function, so we know we have to break this up into a piecewise function. So that's important for us to think about. We also have to think about the fact that it's a rational expression that involves an absolute value. So we have to also think about how could I simplify that to make it easier for us to graph. So normally an absolute value function is our v function, right? Where we have, this is our x and y, and the values for the y values for positive x's and positive y or negative x's are exactly the same. So how is that going to work? Well, let's just take a look at this absolute value section right here. As long as our x values are positive, we're not really going to have an issue, right? Because we're going to take the absolute value of that. So if x was 4, 4 minus 3 is 1, and then that's fine. But if x is less than 3, if x was negative 2, for example, then we're going to have a negative number there. So that's something to consider. So that 3 is going to be our dividing section of our graph. So what happens when x is 3? So that's why we're analyzing it when x is equal to 3. Because this function here, we're going to want to move it over, and we're going to do some fun things with transformations as well, if I was just looking at just the numerator section there. So what happens when x is greater than 3? Well, we know that for our absolute value function, if I wanted to split this up, it would just be x minus 3 over x minus 3. So as long as x is greater than 3, we're just going to do that function and forget about there was absolute value signs there. And if we look at this function, x minus 3 divided by x minus 3 is actually the same as 1. So when the function is greater, when the x values are greater than 3, the function will have a value of 1. But what happens when the x values are less than 3? So what happens if this was 2 or 1 or negative 5, for example? We still want that y value to be positive. So the way to get around that would be to multiply this x minus 3 by a negative 1. Because that way, let's say x was equal to 2, we know that we would have, we want this answer to be positive based on the notion of our function right there and our graph. So we would have 2 minus 3, and 2 minus 3 is the same as negative 1, but we know it can't be negative 1 because we're taking the absolute value of that. So this negative sign out front, takes into consideration the absolute value sign to make it positive. So it'd be negative x minus 3 over x minus 3. But that would be negative 1 if I were to simplify that. And we know that our x couldn't be 3 for this situation because then the new denominator would be 0. So we're going to have a continuity or a discontinuity at x is equal to 3. So we know that x can't equal 3, otherwise the denominator will be 0. Actually, the whole thing would be 0. It would be 0 over 0 because it would create that indeterminate form. And so that's okay. So we know that there's going to be a hole at the point x is equal to 3. And so we're going to have a discontinuity there. Now we have to graph this to figure out what type of discontinuity it is. So let's just do a quick sketch. On the Cartesian plane, doesn't have to be perfect. And what is happening when x is greater than 3? Well, when x is greater than 3, then we're going to have all of our y values will be 1. So here's my 3, there's my 1, and I'm going to do a hole there, and it's going to go right there. So anything greater than 3 is going to be positive 1. Anything less than 3 is going to be negative 1. So here's my 3. I'm going to go down to negative 1, draw my hole, and then draw my line that goes through that. So that is my function right there. And so if I want to think about what type of discontinuity is, I want to see what happens when I trace my finger along the graph. I'm going along this green line, and I get to this point, and I have to jump up to this red line. And so because I'm jumping from one spot to the next, that's called a jump discontinuity. And we also can say that the limit is not going to exist at x equals 3 because the limit from as it approaches from the left side won't equal the same limit as x approaches 3 from the right side. So the limit at x equals 3 doesn't exist, and we have a jump discontinuity there.